now we take a Nylaflow tube and we slip it carefully down that drilled hole. Till about 6 inches come out the inboard end. And we push it into the trough, hoping for a firm, tight fit. Something that will require no secondary means of retainment. Graceful one. This stage, we're going to bond the trailing edge of the main wing to the extrusion. The extrusion is approximately 11-12 feet in length. I've sanded the first 1/4 inch lightly with 80 grit. I've checked the bottom side to make sure that it was already sanded when we surfaced the opposite side. We check its fit, drop it down into the jigs. Make sure everything fits. Now pick the wing up, and you have just enough latitude in your jigs to be able to move it fore and aft. Right now we're doing a trailing edge straight assessment. And what I see here is that this edge from about here climbs just a little bit. And I'll bond this down. This fits really well, its entire length, but I have to bond it down well enough so that when I go to pick the wing up, if I vacuum bag, and by the way, you twist your trailing edge aluminum just far enough to help line up with the bottom of the wing skin. Now that I've checked it and I know where I have to have attachment to keep it straight, I'm going to put Bondo in this area, in this area. I don't need it here really, and I'm going to run Bondo from here to about here. Your wing will be different. Exactly how different is no way to tell. Just make sure that it's bonded enough so that the extrusion stays with the trailing edge when you pick it up to put your bagging materials underneath the wing if you so choose to do so. Cut. Don't worry about understanding it, just record and use the effect. Okay. Now that we've checked the relationship of this straight edge to the trailing edge, we pull the wing forward again. And we get the extrusion up out of the slots for it, and we mix up Bondo. We won't put you through mixing Bondo. We'll be back to you in a moment with Bondo attached and the installation of that trailing edge to the extrusion. Here's a flat cut-off end of a stick, and I've been mixing for about 30 seconds. Don't mix it too hot as a batch, because you have quite a bit to put on. You don't need a lot. Wherever you put the Bondo, just make sure that your trailing edge is pressed firmly into that particular area. Because if you vacuum bag this, the vacuum bagging will push the trailing edge down on either side of where your Bondo isn't, or wherever it is. And this is the area I was talking about before, where the trailing edge did not match perfectly to the extrusion. Now when I get this extrusion dropped down in here and the wing pushed back over top of it again, then I'll take another straight edge and push down on top of it. I'm going to tilt it forward. It's tilted as much as there I go, right there. Tilt it a little bit more. I'm well attached here, well attached here. If you have a weight or of some sort to span across here and push down on this, you don't become a fixture. The application of Bondo intermittently presupposes that one is not going to vacuum bag their wing. The Bondo supports the trailing edge in the precise angle that the Bondo sets. So we have, in this area, free spanning portions of carbon that, if it was not being vacuum bagged, would end up in the correct relationship to the rest of the wing. So for those who are going to vacuum bag, what we're going to do is we're going to take an extrusion, and this can be done from the very origin of this process without Bondo. And we're going to wick super glue into this corner just to support it during the vacuum bagging process. That'll set up. If the trailing edge wants to stay where it is without the extrusion, then you needn't bother with the extrusion, and it seems to be doing just exactly that. Pretty well supported. Super glue has excellent capillative qualities. It will run underneath, and when you smack it with a chisel, it will fracture in a crystalline sort of fashion that will lend itself to easy removal of the extrusion. This area looks like it is not in need of an extrusion to hold it in place, so I'll simply capillate in the cyanacrylate. Looking good. And we'll do this the rest of the way on the wing wherever it's necessary, and then we'll get back into the meat of actually laminating this surface. Super glue catalyst. You can use your thumb on the back side of the extrusion as a guide, your fingertips here. Keep you from bumping the foam. And stand just to the point where you see the carbon fiber. Now, this was peel slide, but this will improve the peel strength and shear strength of your material substantially. So just lightly sand. You can start to see where the carbon fiber is exposed. That's what we're trying to accomplish. And whether or not you use the super glue kicker, you are going to sand this trailing edge anyway. Any area that you peel ply, you must sand. Now that we have our trailing edge bonded in place, Note that the inboard block of foam is sitting there with a nail stuck in it. What we need to do now is make sure that everything is prepped. The red lines are where your peel fly goes. Let's look up here. The area around the bolt access has been prepped for flocks. The top of that plate, that hasn't been rounded to accept the laminate that goes around that upper leading edge section, and nor has this one. So we've got that to do. And that block of foam that we saw, we need to get it plugged into this end, and we need to make sure, see that piece of Nylaflow there? It's going to get in the way of that foam block, so we got to make sure that it's up out of the way when we stuff that foam block in. And we're going to push the foam block aft to make sure this area is supported. And that's again for those individuals who are going to vacuum bag it are most concerned. We also need to cover this end of both extrusions. And we've been... Okay, so as I mentioned before, we're going to plug up the other end of that extrusion. And get that foam block in there. Round the end of that aluminum. Right here, take that edge off. The same thing on the other one. We're going to get our peel ply out, get our spark cap tape out. And we're going back to quartz spheres for slurry because of the retardation that in the curing process that occurs with the phenolic microspheres. And we'll do the cap first. We'll be back to you as we begin the cap process.
And we're rolling.
Well, this is the first step of spark cap. It is presently about 6 o'clock in the evening, and we'll be able to do the entire layup of the spark cap in about an hour and a half to 2 hours, followed by slurry, this time using the quartz cell I may have mentioned. And you'll notice I'm putting it on very wet. I've blown all the dust off of the surfaces. If you see any particulate matter, get rid of it. Don't leave it sitting on top of your wing forgotten, though. It'll end up buried under something. Halfway into the spark cap, I've got 6 plies all the way out to the end, and I'm starting to taper back. I've got 7 in here now, and I'll continue on until I get all the plies in place, and we'll be back to you after the spark cap is complete. What we have, we've put flocks around the perimeter of the block, and the block is radiused. I have a little transition here to do with the flocks to make sure there's no gaps. You can see how the fibers taper from 6 plies, 7, 8, 9, 10, 11, 12, 13, 14, and 15 plies, give or take 2 plies. And I've got flocks on one side, now I build up flocks on the other. Make sure I have a good transition from the face of the shear web to this corner. Make sure that I've got plenty of flocks in these corners. Now this area here has a tendency to get kind of square when we bag all this up. So we're going to fill up any gaposis that might be along this edge. And I'll do this the entire length to make sure that when this gets bagged I have no gaps. The rest of it looks pretty smooth. Should wrap pretty well. Now then, we're going to put resin around the perimeter of the bolt access depression. Make sure it's well painted all the way around. Now, if you recall, we overfill this slightly. Some of the flux always variably gets imparted into the laminate as you're putting the carbon down. So you want to make sure that you have more there than you need. We'll be back to you in a moment after we're done with the floxing, and we'll start the slurry process. We're about to mix up a massive batch of slurry, approximately 20 shots of resin, if I remember correctly. After the slurry goes in place, we'll place peel ply between the red lines, do a dry micro fill over our conduit, paint pure resin onto the sanded trailing edge, paint pure resin onto the sanded leading edge, back 2 inches, and then put dry micro in any of the small indentations created by drywall screws, here, and little areas alongside the spar cap, and then we'll apply. All right, we're just getting the last bit of the micro slurry. Something I want to show you on tape. If you look at the slurry, you see this blue particles of foam in it. It acts a bit like dry micro. It can be used in areas where you need materials with high bulk. It won't run. There's a depression right there. And when you run out of that material, there's 30 shots of resin on this presently, and it's scraped very dry. If I run my squeegee across this, what we do is we leave the pores filled, but no extra resin behind. If you find depressions and holes, fill that with dry micro. Case in point. Push dry micro into the holes, make sure they're filled, and then leave it just ever so slightly high in the area. Push it deeply into the hole, and then scrape it off. Now that we've slurried and we've done all the dry micro and all the flux, we paint pure resin onto any area where we're going to go carbon to carbon. We'll do this underneath the center line of the leading edge. Putting the peel ply down can be a bit of a pain, and getting it to stick. So we'll brush pure resin. This has gotten to be a little on the aged side, but it's 2187, so we have a bit of time. Ignore this first line. Our concern is these out 2 lines. Now those of you who are thinking, oh, the extra resin, this is going to be in the peel ply area, and we'll end up coming right out with the peel ply. So we'll paint between all the red lines like this, everywhere on the wing, wetting the underside of the leading edge back 2 inches, and putting the peel ply down. And when we get to the point where we're putting the peel ply down, we'll come back and show you what that looks like. Okay, let's clean a squeegee here. Don't have to have an assistance for this, but certainly couldn't hurt. The aft edge, closest to me, is the hinge line. The forward edge will be the inside scissors
at the end of the table.
We cut about 2/10 of an inch off of this material. It represents the end. Don't lap the peel ply and don't go out onto your trailing edge. We'll do the same thing like that on the other end. And we'll do that same operation in this area. And then we'll come onto this side of the line. The line represents 90 degrees to the forward face of the shear web. We'll run a 2-inch wide tape in here for a very deep rib. And we'll get back to when we would start laying on the first skin. All right, we've got our carbon on. Let's not forget the layer of glass on top of the aluminum. We've got our transitional flocks in place. And we can go ahead and wet the front face of our main spar, or our front face of our shear web. We lap the top about a ½ inch or so. Make sure there's no air left in there. All this is an insulator, nothing else. Now we take this one. Perform the same function. You can use the glass to shape the carbon right in the corners. And you'll notice that I'm a little generous with the resin, but we're going to bag this and we're going to heat it a little bit. I encourage you, if you are not bagging, be very careful with your resin application. Don't over wet. I'm using the glass cloth to help shape the flocks underneath and to push the air out. And I'm going to lay my carbon back down again. I want you to get a look at this corner. See that I got the carbon all the way against this edge. Make sure that my grain orientation is straight. And wrap around this corner. And you can feel the carbon still soft on the edge. Use your carbon on the exterior to shape the carbon spar cap underneath to a nice radius. Load transition occurs in this corner. The flocks that you applied along that corner to fill any possible gaps and we'll wet this out and go on with the next ply. Okay, start. Remember I mentioned we got all the prep done first, folks? Well, this is part of the prep, getting the resin under the wing onto the sanded section so that we can then wrap the leading edge around, coming around the front, maintaining the same grain orientation. You can see the grain is convection, so you don't wrap straight in, you wrap kind of diagonally so that you don't create folds. Pull it as you go around the leading edge. Put tension on it. Straightening fibers at the same time. If you did this transition right in the front, you should feel no bumps as you go around that leading edge. I'm going to wet the rest of this out, and we'll be back to you as we put down the next layer of glass carbon. Okay. We just laid down the second ply. Make sure that this edge is straight. Excuse me. Leading edge is trimmed and wrapped. Cut the ends. And ride right along on top of the aluminum extrusion. Sliding along up against the trailing edge. Now I'll take the brush and I'll stipple that down. And I'll wet this edge. Once I've got this edge wetted, and I take this edge, butt it up against it, no laps, and wet the whole thing out, and then we'll follow with our third ply. At the end of every laminate on a main wing, the last thing we want to check is just to make sure that your leading edge is, at the very least, rich. You don't want to leave that leading edge lean. Something you're going to grind and taper off as it is, and it is an area where load transitions torsionally. So make sure that you have good leading edge structural integrity. Look for air. Make sure you have plenty of resin. As you wrap your end around the leading edge, you shouldn't hang up on a dry spot. Just be able to slip and slide on that leading edge. This is one of the reasons that we have you, when you jig your wing, make sure that your leading edge is close to the edge of your table so you can easily get underneath and stipple this leading edge down. Oh, one dry spot there. That is gorgeous. Now we put on the last ply, the one that runs span-wise up to, and if you come up, you can see clearly. There's the peel ply. You can see it marked. Can you see that in the lens, Misha?
Not yet.
Can you see it now?
Yeah.
This point here is the hinge line of the aileron, the back side of that. So we'll run our unidirectional material span-wise right along that edge. And we'll be back with that in a moment. Okay, what we're going to do now is we get the last ply on, and Misha on the opposite end is going to pull 2 palms down. If you look at the cloth, you'll actually see the fibers pulling straight, lining up. Misha shifted that in. There you go. If you have minor ripples like this, you pull them out and then pull tight again. Come back down again. Okay. Very good. No such thing as perfectly straight. It's all relative. Now I'll cut to this corner and wrap that over the last 3 inches of the forward face of the shear web. We'll wet this out, and we'll be back with you in a bit. Okay. Filming. I can't hear you.
With the heat gun going, it's going to be very hard to hear you.
I got no choice.
Okay. Speak up loud.
If you are not vacuum bagging your wing, then you have got to go through an interesting ritual of over-wetting each and every ply, and then removing the resin very carefully. What you're going to see is this. You can wet ahead of yourself and then suck up the resin. With carbon fiber, there's no way to see how much air you have in the laminate. So you simply have to assume you have a lot of air, and the way you get rid of that is to over-wet your structures. With 2187 resin, the resin stays wet for so long that you can get rid of those excesses with a careful application of heat and pattern stippling or pattern squeegeeing. Do this carefully over the entire wing. The first laminate put on wet. Second laminate squeegee carefully with the application of heat and careful application of resin. The third ply, massive applications of resin, and then good pattern squeegeeing, and then careful application of heat and the removal of that resin. And we're getting a nice flat look. Not getting much resin out of this area. Now some of this resin I can take back to the underside of my leading edge. Do be careful with the heat. Don't stop and allow your heat gun to point at your surface while you're squeegeeing someplace else, because you'll melt a hole through your wing. So do be careful. And we have 2 more small pieces to put on this end, a unidirectional laminate to put in this area, and 3 plies of unique carbon fiber tapering in length across the leading edge of the shear web. We'll come back to you and show you what that looks like in the last. Now that we've got all the plies on, leading edges are wet, and the added unidirectional reinforcement tapes are in these areas, here and here, and the 2 plies of carbon fiber unidirectional. First one at a 45 degrees to the spar, second one 90 degrees to the first one. So we have the equivalent of a ply of bid of carbon fiber out here. Wet this out. Tuck it into the corners. This is something you can do for either vacuum bagging or for a standard wet out wing. with 2187. It helps you get extra resin out. You never wet out Dacron in this process. The Dacron is here to do a number of things. Wetting it out is not one of them. We're putting it on to get rid of resin and to help make laminate transitions. And in vacuum bagging, it helps prevent the vacuum bag process from putting creases in the laminate itself. Get all of these creases out. We'll get this finished. Now that we've skinned the wing surface and surfaced its top side, the next step is to prepare the inboard end of the wing for a 3-ply bias laminate. We'll start by carving foam and preparing for that laminate. We'll start on that in a few moments. The first step in this preparation is the removal of the foam from the forward face of the shear web. There's our aluminum. I might add here that what you do is you remove foam up to this depth, but not any further up. You leave this 6/10 of an inch of foam all the way across. If you remember the peel ply we put on this forward face, it ran all the way from 6/10 of an inch from this surface, all the way to the bottom and all the way to where the spark cap ends on the bottom surface. So we'll remove this foam as well. There's the peel ply to gouge that up. I'm going to go get a file and continue this process. The spark cap ends approximately here. I take a file or a saw and I cut diagonally towards that point, tapering my foam to where the spark cap begins. Absolute precision here isn't important. This does take a bit of time. I won't put you through all of this process, but some of the finer points I will show you. One of them is this transition. This bit of carbon fiber here gets pulled. There is our transition to the spark cap right there. We removed 3/4 of an inch of material from the edge. There's your spark cap right there. go digging for peel ply. There it is. Now we have to remove the foam from the trailing edge right up to the back end, or we'll damage our peel ply when we go to pull it out. We bevel the foam right to nothing, to this, from this edge directly to the beveled edge. Directly beneath this torque tube port, we have to remove foam to provide sufficient room for the torque tube control arm to move without interference. So we sand down into this depression well forward of a line perpendicular from the center line of this surface. We do leave a small web of foam at the bottom. I'm going to go ahead and bevel the rest of this section and come back to you when I have something new to show you. Pick it up just to the point where I'm touching aluminum. Peel this up. What we're removing is all of that micro. This wasn't in the original long easy plans. And after sanding a number of wings in this area, removing all the micro, it just struck me that there's got to be an easier way. Removing all the micro in the corners, things that might upset the grain orientation of material. And I'm going right into the corner, making this surface transition right square to the corner, this surface and this surface. Now we have a layer of peel ply under this surface as well, going in approximately 3/4 of an inch. And we're going to remove that peel ply as well, all the way back to this corner, and it'll look just like this face, except that we'll leave the foam in here beyond the 6/10 of an inch. And I'll get a hold of this and peel it off and show that to you in a moment. Okay, we've got a hold of the peel ply that went around this corner, and I believe that this first piece of peel ply ends right here. Then we continue with the peel ply in this edge. First thing you gotta do is find it. You saw how easy the first piece went. Well, if you remove the foam first, that's what you can expect to occur. If you don't, you can expect the latter to occur. So do remove the peel ply first. Are you as impatient with watching me as I am with doing it? Maybe it appears so. All right, let's see what we get this time. There we go. Now anything that's left in here we'll dig out, make a nice transition in the corner, and Okay, we've removed all the foam on the upper section. You can see the spark cap exposed up above. And the foam cleaned all the way around the aluminum plate. The foam cleaned up around the perimeter, right to the trailing edge. And we'll show you what the underside of that looks like. All the way back to the corner. That brown line you see there in that upper skin was where foam broke off, and we bonded it back in place. That edge will, when we slurry it, will be heavy slurry, dry micro in all the corners. These surfaces, the glass surfaces, will be sanded. You can see right next there to the aluminum block, it's been sanded some. We sand the first layer of resin off and get right to the fibers. And in the next section we'll show you the application. One of the things I may not have mentioned in that last showing is the depression below the torque tube. The base, you see that small black dot, is nearly exposed to the skin. It's about a 1/16 of an inch thick right there. The web between the depression and the outside edge is approximately 3/4 of an inch wide and about a 1/2 inch thick at its highest point. All the surfaces have been sanded since the last shot. Around the plate has been sanded. The undersurface of this edge has been sanded. The lower edge has been sanded. Pardon the automatic focus. Now we're going to go over here to the BL 55.5 rib. We're going to cut that off 90 degrees to the forward face of the shear web and then carve it out. We'll get all these things prepared before. In preparation for removal of this section of the BL 55.5 rib, we find the corner here, and then we take a square, set it against the forward face, establish that is in place. I'm not sure you can see the red line here, but when we marked where the peel ply goes, which runs from here to here, you can see the red line right through it. If you can still see the line and can depend upon it, then you use it as a guide. We'll cut along that line all the way around, both sides. We'll lift it up off the jig, flip it over, do the same thing on the opposing side, make sure that the two surfaces are perfectly parallel, sand them flush, and then we'll go in 2 inches from this cut line, from here to approximately here, and create a 2-inch wide deep rib or C-section that the glass laminate will lap against the forward face of the shear web in this area here. And we'll get back to you when we make that cut. Now, one of the things that I wanted to mention to you here is that there's a common mistake made, and someone places a straight edge on the first portion of the square line, and they lay it flat on top of the wing, and then they begin to bend it around, and it still looks good, but what happens at the bottom is that it curves, makes a crescent, an exaggeration like this. To make this line perpendicular its entire length to this forward face, we have to maintain a level plane, like so, and then you need the hands of a friend to make the mark. Essentially what I'm doing is, if I was to bring this all the way down, what you would see is that this plane remains parallel to the forward face of this at all times. So I'm actually up off this surface, and then I bend it around, and it gets more profoundly away from the surface as I bend it down. And you can sight down from above to see if it is actually a straight line. Now I'll get Richard here in a moment to describe this. And we've flipped the wing, and we've placed the square on the forward face of the shear web. And then checked our reference point here that we scribed from the top side, made sure that the two lined up, and then connected the top point to the bottom point. Now we'll remove the skin from the bottom side, flip it over, remove the skin from... Well, now that we've removed the foam skins, we'll take a crosscut saw, the carbon skins, we'll take a crosscut saw and cut the foam from above to below, and then sand. This is going to be in front of your lens, and so is this. Filming? Okay, now we've got the make sure we're not going through. Carbon fiber. There's what we were going through before. This particular edge defines the part line between the strake and the wing. And it's one of the most obvious points on the airplane. When people come up and look at your machine, this will say to them whether or not you have paid attention to detail. So make that a straight line. Now I'm going to flip the wing over, sand the bottom side as a perfect parallel. You'll be able to look down from above or from below to see if the two surfaces parallel. Okay, now that you've trimmed the material, we measure over 1 7/8. Gives you an 1/8 inch fudge factor. I'm using a pair of dividers. Actually, it's a compass. So easy to see pencil on top of carbon. Being facetious, of course. Now we'll do this on the opposite side, and then begin to carve foam down till we get to about that level. And we'll be back to you once we're in process. This is one way to remove micro. And after having done this, risking pulling up a small amount of carbon, we take sandpaper, carbon coming painfully into view, or if we remember to put the peel ply in place, we pull peel ply from under the center line leading edge. I should be working with a knife here and peeling this up. All that micro ends up on your peel ply. And the surfaces end up just super, super clean. If you can get underneath there and take a look at that. From down here, Richard. All I have left to do is very light sanding on that section and make sure that all this surface is relatively flat from this surface to this surface. Remove the micro from this surface. We put a micro corner in here, slurry this surface, and put 3 plies of bid glass on this surface. Now that you've done all your foam preparation, you've gone over the surface with 80 grit, sanded it smooth, checked all the corners, sanded everything here. You mix up a very, relatively speaking, very dry mixture of slurry. And the reason we do this is that you're working in a very awkward area. You're working inverted, working on the vertical, and this is going to help keep the glass in place on your first and most difficult ply. We're going to slurry the entire interior. Don't fill the voids and cracks and such with this particular mixture. After you get the flats filled with slurry, we're going to go back and fill the dents and imperfections with a drier mix of the same material, a literally dry micro. So we're not going to drag you through this whole process, but we'll be back to you when we start on the dry micro. Well, now that we've got it all microed, we have dry micro in the corners, dry micro up these faces. Now we need to paint these surfaces, this surface, the aluminum, the perimeter with pure epoxy, and then apply flocks around the perimeter of the aluminum block. What we've been working on as well is the forward rib. This section here. A total of 4 shots of resin were mixed. And you can see the dry micro in this area. Sanding all the way around the perimeter, the slurry on the faces, and we'll apply 3 plies of bid to this interior. We have to brush pure resin onto the on the sanded surfaces. Now we've got some flocks mixed up. This corner is always a bit of a problem, so we're going to fill the back edge of this with pure flocks to help make the transition easy.